Welcome to the chapter on materials science. This fundamental field in civil engineering focuses on understanding the properties, behavior, and performance of construction materials. In this chapter, we will explore the properties of materials, various construction materials, and the importance of sustainability in materials science. Understanding the properties of materials is crucial for selecting the right materials for construction projects. The key properties include mechanical, thermal, electrical, and chemical properties. Mechanical properties are essential for determining how materials will behave under various forces. These include strength, elasticity, ductility, and hardness. Strength is the ability of a material to withstand an applied force without failure. It is measured in terms of stress, which is the force per unit area. The formula for stress is sigma equals F divided by A, where F is the applied force and A is the cross-sectional area. Elasticity is the ability of a material to return to its original shape after the removal of a load. Hooke's law describes this behavior with the formula sigma equals E times epsilon, where E is the modulus of elasticity, also known as Young's modulus, and epsilon is the strain. Ductility is the ability of a material to deform plastically before fracturing. It is often measured by the percentage elongation or reduction in area during a tensile test. Hardness is the resistance of a material to deformation, particularly permanent deformation, scratching, cutting, or abrasion. Thermal properties include thermal conductivity and thermal expansion. Thermal conductivity is the ability of a material to conduct heat, while thermal expansion is the tendency of a material to change its dimensions in response to a change in temperature. Thermal conductivity is the ability of a material to conduct heat. It is denoted by K and measured in watts per meter per Kelvin. Thermal expansion is the tendency of a material to change its dimensions in response to a change in temperature. The coefficient of thermal expansion, alpha, is given by the formula delta L equals alpha times L naught times delta T, where delta L is the change in length, L naught is the original length, and delta T is the change in temperature. Electrical properties include conductivity, which is the ability of a material to conduct electric current. Conductivity is the reciprocal of resistivity, given by the formula sigma equals 1 divided by rho, where sigma is the electrical conductivity. Chemical properties include corrosion resistance, which is the ability of a material to withstand degradation due to chemical reactions with its environment. Construction materials are the backbone of any civil engineering project. Some of the most commonly used materials include concrete, steel, and wood. Concrete is a composite material composed of coarse aggregate bonded together with a fluid cement that hardens over time. The key properties of concrete include compressive strength and workability. Steel is an alloy of iron and carbon, widely used in construction due to its high strength and ductility. Important properties of steel include tensile strength and yield strength. Wood is a natural material used in construction for thousands of years. Its properties include a high strength-to-weight ratio, making it ideal for lightweight structures and good thermal and sound insulation properties. Sustainability in material science involves selecting and using materials in a way that minimizes environmental impact. Key considerations include recyclability, renewable materials, low-impact materials, and energy efficiency. Steel is highly recyclable and can be reused without significant loss of quality. While concrete itself is not easily recyclable, crushed concrete can be used as aggregate in new concrete or as base material for roads. Wood is a renewable resource and is sustainable when sourced from responsibly managed forests. Bamboo is a fast-growing plant that can be used as a sustainable alternative to traditional wood. Using materials with high thermal insulation properties can reduce the energy required for heating and cooling buildings. A real-life example of sustainable construction is the Bullitt Center in Seattle, Washington. This building is designed to be one of the greenest commercial buildings in the world, featuring solar panels to generate renewable energy, rainwater harvesting to reduce water consumption, and sustainable materials, including FSC certified wood and low VOC materials. By understanding the properties of materials, selecting appropriate construction materials, and considering sustainability, civil engineers can design and build structures that are not only functional and durable, but also environmentally responsible. Thank you for watching this chapter on materials science. We hope you found it informative and useful for your studies in civil engineering.